Welcome to the Loughborough Sportcast, where we seek to bring together the worlds of academia and professional practice. If you're interested in the latest research and trends in the world of sport and want to hear from experts from around the world, then this is the podcast for you. I'm your host, Martin Foster, Applied Sport Management Lead at Loughborough University. This week I'm joined by Professor JB Morin and Dr. Bill Horg. JB is a professor and researcher of Inter-University Laboratory Human Movement Science at Université Jean Monnet, Saint-Étienne, France. Bill is the Applied Strength and Conditioning Lead at Loughborough University. Today we're going to talk to JB about measuring force, velocity and power in jumping and sprinting. We'll hear the importance of individualisation and how stronger does not always mean faster. We'll hear about the simple methods that can be used to measure force, velocity and power in the field without the need for a force platform. Hi Bill, hi JB. Can you give us a brief introduction to yourselves? So Bill, a brief introduction for our listeners.
So I'm Bill Horg. I work here on campus. My position is Strength and Conditioning Lead, and basically I'm the bridge between school and sport here. My research interests are very much in line with what JB does, but also how technique changes and develops with athletic training. So, where your work right now is kind of looking more from a macroscopic scale. I'm obviously incredibly interested in it, but I'm also interested in kind of that next level down. Yeah. So kind of, as I was telling you yesterday, where physics meets physiology, I guess, right?
Totally.
Yeah.
Okay, JB, what about yourself? Brief introduction to yourself?
Yeah, so I'm a full professor. I've been working in research around sports science for 15 years now. My PhD was in 2004. And my main research interest right now is how people can improve their jumping, sprinting, and running abilities from a biomechanical perspective mainly. But to me, biomechanics is physiology and vice versa. It's not. Yeah. I mean, yes, we are one entity. So, yeah, that's what I do.
Okay. So,
Martin, I just to jump in quick, I was telling JB this. I feel like the work that JB's been doing these last 10 or 15 years, I think it's the most influential work in our field for as far back as I can remember. I mean, it really is. I mean, it's that big a deal.
That's very kind of you.
It's true though, JB. It really is. It's nice to recognize that.
It's absolutely not my work. It's definitely a teamwork. I mean, we are several guys working.
Yeah. Sorry.
I've got to be honest. I'm down the corridor from Bill, and he has been very excited about you coming for quite a while.
Yeah.
So I was going to look at limiting the amount of coffee he had before we got here. So we'll see how things go. Right. So let's just kind of get into things. I heard a nice introduction from you regarding how you conduct your research. Can you just kind of tell our listeners about that?
Yeah, so basically what we try to do is to get some questions from the field, like performance questions. How can we improve that? Is that training method really effective, etc., etc.? Then we try to step away from that and go back to the biomechanics, the laws of motion, the physiology, sometimes mathematics and modeling, and see what answers we can bring. Yes, no, what methods we can bring. And then the last step is the step I tend to prefer is we go back to the field with the answers we think we can bring, and we discuss these answers with practitioners. And then we have new questions, and it's like a full cycle. And as I said to Bill yesterday, when we publish papers, some colleagues think that a paper published is the end of a process, and I really think a paper published is the beginning of a process. The beginning of that paper will be applied, or that paper will be criticized, or that paper will generate some new research questions. So it's basically a full cycle.
Yeah, I really like that full cycle that you talk about, because a lot of the time you've got people who are doing the theory and then others who are doing the practice, but you linking it all together yourself and with the team that you work with is just a really nice feel to bring everything together and have that holistic understanding of the whole process. So we'll touch upon that as we go through talking about things that you've been looking into. So with what we're going to talk about today, can you start it off with the force velocity spectrum and just explain to our listeners what that is, and we'll go into some depth later on.
Yeah, so basically anybody knows, even those who are not into physiology, that your muscles are not able to produce the same amount of force in different velocity contexts, and vice versa. You all know that you cannot lift a heavy load as fast as you would lift a light load. This is proof that the muscle works like that. So the velocity or the load context induces a different force level, force capability. So when you assess for any given individual that spectrum, you go from the maximum possible force output to the maximum possible velocity output, and this gives you a spectrum for the athlete. And what we observed is that some athletes are really good on some parts of that spectrum, not on other parts, and vice versa. And so the entire approach is measure that spectrum, interpret that spectrum with your individual, and then go and try and find some paces for improvement. Yeah, that's basically what the FV spectrum is.
Yesterday you gave us a few analogies of that. So you used a sports car and a tractor.
Yeah.
Could you just explain that to us and then put that into context of actual...
I always say that life and sports would be super cool if we were able to produce the same amount of force, whatever the velocity of motion. Take pedaling, because I think it's a very simple exercise. When you push the pedal at the start of a sprint, you know you can push very hard on that pedal, okay? If you take this amount of force and you put it onto the pedal at every pedal downstroke down the road, you would fly, basically.
You'd almost, without wind resistance, you'd accelerate infinitely, right?
Yeah, absolutely. Or you would go super fast. But the physiology says, so this is the motor side of things. But the physiology says, like, if you have a sports car and you're driving 100 miles an hour and you push the pedal, you can still accelerate, and that's cool. But the body cannot. The physiology says when the velocity increases, your force capability will decrease. All right, so that's where we have that spectrum. And the idea of the training, for example, for a track cyclist is to be able to produce the maximum amount of force at every pedal downstroke, down the sprint, and so at every possible velocity. So the velocity context is key.
How do you profile an athlete? So specifically, what tests do you use to profile that athlete?
Yeah, so basically, if you go back 15 years ago, 10 years ago, you had no choice but using very specific lab equipment, such as force plates or force transducers or video cameras. So that was heavy and costly. And with the works of my young colleague Pierre Samozino in France, we were able to validate some computation methods that assess the force and the velocity output in, for example, jumping, sprinting, but also at the bench press in a much simpler way, which means the inputs are now only flight time during a jump that you can measure accurately with a phone, for example, or split times during a sprint. So we can assess the macroscopic force velocity output from now very simple and field devices.
And how do you then use that? So you've got the information about the spectrum.
Yeah.
How do you use that?
So basically, if you measure someone jumping, if you measure a jump height, or if you measure a sprint time, you only have a very rough performance information, okay? You don't know what are the underlying mechanical variables that lead to that performance. So basically, how to use that is to have that spectrum and to know what capabilities caused the performance you observed. And very simply, you can have two athletes with the same jump height or with the same sprint time, and they will display very different force velocity spectrums. Well, sometimes they will display exactly the same spectrum, of course, but they can have very different spectrums. And that's important because it says the performance output is caused by different biomechanical combinations. And then, in terms of training, you can better individualize the approach. That's a summary of the approach.
So the basics are, from my understanding, that somebody can produce force and have a higher maximum force, but in terms of velocity, somebody else might produce higher velocity, but their maximum force isn't, so they'll accelerate quicker,
Yes.
but they won't be able to hold it as long. Is it we're going into those contexts?
Yeah, you go into the context because it's all. We used to differentiate strong and fast. This is a mistake because you should be strong and strong. If you want to perform well in a sprint, for example, you should be strong at low velocities and also strong at high velocities. So basically, to give you an example, you will assess a rugby player. He has very, very high maximum strength, but is not that good with light load. So the spectrum is very steep, he's very force oriented. His jump height might be suboptimal. So if you want that rugby player to improve jump height, you know that you will work on something different from maximum force. So you will stimulate other parts of the profile. And we have examples all over the place of people like this.
So with someone like that, in terms of stimulating that profile, what would you select exercise-wise to try and do? You showed some cool videos yesterday.
Yeah, so this is definitely the area for future researches, and I tend to say that's going to be the community, not our own researches. We went very straightforward with very simple and very few exercises, because we wanted to stimulate the profile with what we thought was effective. So we had horizontal pushes. We also had some assisted jumps. And the idea is very simple. We don't care much if these exercises are popular, used by famous coaches, or we just care that biomechanically speaking, they induce what we want to stimulate. You see what I mean? For example, this horizontal push, I had never seen that before, except in swimmers with a row with the upper limb.
Yes.
But mechanically speaking, this exercise totally makes sense. So I don't care much if it's used or not by these top coaches. When we measure the velocity output when you do a horizontal jump on a board, it's much faster than when you do a vertical squat jump. So we think, because one of the principles of training is specificity, we think that we have the specific conditions to stimulate the fast part of the curve.
So if an athlete was going to leave during a regular vertical jump at like 3 meters a second, what do you reckon the final velocity is on a horizontal sled?
Yeah, so basically we've published a comparison on that. So basically it's something between 10 and 20% faster.
Yeah, okay.
So it's not that fast. To tell
Which
you
is probably good though, right?
It's still something. I mean,
no, that's
it's still something.
Yeah.
But when you take off at 3 meters per second over a squat jump, when the same individual takes off over the board, it's something like plus 10-20%.
Yeah.
We also went to assist the horizontal jump. We wanted to go.
Wait, so what was that?
We basically wanted to go to the limit of the athlete not being able to push anymore. It was a bit faster.
So basically, your point was you were trying to actually get to the theoretical.
Totally.
Wait, that's crazy.
Yeah, that was fun.
So what velocity? So if it's a 3 meter per second jumper, what?
It was something
velocity?
like, so the assistant provided an even faster motion.
Yeah, that's crazy.
And we went to the point where the guys extending their limb, but they did not even touch the force. Yes, because it was just free.
That's
free
wild.
Push. Yeah.
Wait, that's wild.
So we wanted to explore that entire spectrum, because the entire training is, in my opinion, skewed due to gravity. Because when you stand, you already have a load on your limbs that's your body weight. So that's a load. So you think it's no load, it's your body weight as a load. So any additional load you put, you will be more on the left side of the curve. So you see what I mean? So in training, we need more situations where you produce force at super fast.
If you don't mind, one thing that really surprised me from the lecture yesterday was how easy it is to make a horizontal jump sledge.
Yeah,
that wasn't intuitive to me.
No.
Because that's a question. So for the listeners out there, I think that would be a good thing. Can you just describe quickly the actual like the cheap apparatus and maybe like the cost of it and where you get it?
So basically you find a comfortable board on which you can lay supine on your back, and good rollers and low friction. Like a long board can do it, like with a
so literally just a good skateboard.
You just need to be able to push on that. I have some of my students bought or stole some, they bought that for €1. I won't drop names, okay? But they get some supermarket carts, these big platforms like IKEA carts, and you lay down on them and you push. And it works. I mean, it's just a freaking board. There's no. But you remove gravity as a resistance when you do that, and that's the key.
But that's nice, because that was definitely something. I mean, I think many of the coaches out there would think of the assisted bands. I think it's kind of something that you.
But it works. I mean, if you use elastic bands and you attach them to the rugby poles and you jump and you assist yourself in jumping, you can push super fast.
Just make sure you're standing back so you don't hit the top of the that's a legitimate concern. Yeah.
But I mean, it's not an issue with possibility. It's just thinking smart and finding solutions, provided you push super fast.
What do you think's changing mechanistically when we're training at higher velocity? I think it's a really important question.
So just to introduce, the discussion should be understood as we don't work systematically at high velocity with everybody. We just do that if the athletes need that. Okay, so the mechanisms is also future researches. For what we know and from what we anticipate, there might be an issue with better coordination to face the task, getting used to contract faster, having more better motor unit recruitment in time, and etc.
You think
so all neural adaptations that are related to having faster macroscopic movements.
Do you think for an athlete with a good training base, do you think they're getting any? Do you think decreased antagonist contribution is still a factor at that at that level?
It's part of what I call better coordination overall.
Yeah,
yes,
okay.
Definitely. I mean, if you we need some studies with EMG, etc., because there's none. But yes, definitely. If you push faster, it's obviously because at some point the overall coordination is more efficient, and this includes better agonist-antagonist ratios activation.
But you know what though, the movement pattern. So at the end of the day, the movement pattern that you're really interested in is jumping with body mass, right?
Yeah.
And the fact that they're already doing a lot of practice with that, right? So to me, like, they're already training the coordination of that movement. So you're giving them something a little bit.
Yes.
It's interesting.
Yes, but body weight is just one load, so it's just one point in the spectrum.
Yeah.
So if the analysis shows that you need to work on other parts of the spectrum, then you will need to stimulate. It's what we call velocity-based training. You will need to be in a condition where the velocity is either super low or super high.
But I mean it from a coordination standpoint, right? Like so to me, driving the relevant units, either recruiting more or probably driving what you are recruiting to a higher right. I mean, greater activation. It's got to be right. It's got to be right.
But it's going to be in different velocity conditions. So it means I anticipate, but I have no evidence on that. But I anticipate that when you jump with an elastic assistance. The coordination in terms of time, muscles, etc., is different.
Yeah, it's got to be, right?
So you may train hours and hours and hours with your body weight and be, let's say, inefficient in a higher velocity condition in terms of neural coordination.
Yeah, okay. No, I see what you're getting. But also, I think it might be worth mentioning, you're also probably getting a little bit more contrast. Like the nervous system, it seems to like specificity, but at the end of the day, it also seems to like a little bit of contrast, if that makes sense. I think you look at, like, I know this is kind of tends to be anecdotal, but at the Olympic Training Center, we were heavily influenced by Bondarchuk. I'm not sure, by Anatoly Bondarchuk, and that seems to be a pretty common theme to his training method, if that makes
sense. We can talk about contrast because the approach, as we see it, is not black or white. It's not 0-1. So it doesn't mean if you need to stimulate your velocity side of the spectrum, then you will prioritize that kind of training. But you will also maintain some other parts because you just don't want to have a trade-off and win something and lose something.
That's definitely something. Can we go along that? If you just look at the work and it says, okay, you need to train, right? You have an imbalance and you need to move more towards higher velocity. Then the intuition is just, okay, let's pick a load on the velocity side and let's just train it. But then but Matt Payne and I were talking and he said, hey, that doesn't necessarily even exclude any of the periodization schemes, right? Totally. It's just where you're putting your focus.
Totally.
Do you mind talking a little bit?
We always wanted our protocols in research to be potentially directly applicable in the field. And that when you train someone, you just don't say, okay, from that week to that week, you just stop everything and you're going to work on that part of the spectrum. So we wanted to have that integrated to the training scheme. So you can have a block approach where you say, okay, it's off season for 8 weeks. We're going to work on that specific part of your profile before resuming training, etc. But you can also integrate that throughout the season, like having, for example, 1/3 of a session specifically on that. But you don't want to totally cut the training and focus on it doesn't make sense to me. And that's where sometimes research protocols are super interesting, the results are super interesting, and coaches who read the papers just say, there's no way I can fit that into my real life scheme. So we should be aware of that right from the beginning in designing research.
So I know that, and you were talking about this yesterday. So I know that the research isn't conclusive on this, but just as a gut, basically we're looking to move towards higher velocity again, and there's kind of an average load that we'd probably like to target. How far are we? I know I'm using my hand here, but are you thinking it's more optimal to kind of train reasonably close to that average, or really deviate the loads in both directions?
That's a call for future research. It's very exciting stuff.
That's
for example,
very exciting, right?
Basically, if I want to improve, let's say my spectrum is correctly balanced, so I need to improve my maximum power, and I need to improve basically the entire curve and shift the entire spectrum. Is it better to work with polarized approach, either super high force or super high velocity, or with a more distributed approach. What's best in terms of physical consequences like injury risk, in terms of adaptations, we don't know. But that's exactly the parallel you can do with middle distance running and endurance sports between the polarized approach, like super high volume of very low pace training, and on the other side, super fast and super high intensity, where your sport doesn't require either of them. These, okay?
Super fascinating.
So I think we are now trying to build studies where we should do that. But if you do that, you have to be very extreme in the load. So you have to find subjects who accept to go either super heavy or super fast. Because if you're somewhere in the middle, that's not polarized. I had the discussion with a handball coach and he said, I'm doing some French contrast or whatever you call it. I'm doing some contrast training. But when we talk about the load, the contrast was jumping with 20% of 1RM on the shoulders. That was the light load, not light.
That's the light load?
And the heavy load was 60% of body mass of 1RM on the shoulder. So if you put these 2 points on the spectrum, they are neighbors in the middle of the spectrum. That's totally not contrast and totally not polarized. So we should really do that.
Speaking along those lines, right? If let's say we're doing a squat jump, let's say the athlete has a back squat of let's say it's a qualified athlete and they have a back squat of 200 kilos.
Yeah, I know that.
How heavy? 200.
10 reps. I can do that over 10 reps.
I'm looking at you right now.
Kilos, not pounds.
I don't think. I question that. How heavy? How heavy are you? If you're really looking polarized, how heavy are you taking them?
That's a very good point, because the first answer is not in terms of load, it's in terms of velocity. So I would answer with the load at which the velocity of motion will be super low, like close to the 1RM. All right?
Yeah, okay.
So whatever load it.
They're trying to jump with that?
You always try to jump. You always try to jump.
Always?
Even if you cannot in the end. Okay? So you push ballistic. Yes, yes. Every time we talk about a load, we talk ballistic. Like you don't control velocity. You give it the max.
What kind of sets and reps are you? I mean, something like that's got to be pretty taxing, right?
Yeah, of course.
So what kind of how often? What kind of sets and reps? I think that'd be really good for people to hear in practice.
I'm not much into recipes, but you should consider that's a session. So for example, if what we used in our study was 3 little sessions a week, but very, very small amount of time. Like it was in total maximum 10 sets. Okay.
Yeah.
But if you go
over the course of the week.
Yeah.
Yeah. Okay.
Over the course of one session. Okay.
Wait, 10 sets?
It was like 3 times 3. That's 9. Okay. Well, sorry. In terms of reps.
Close to that. Reps. Yeah. Yes, okay. No.
So,
that sounds.
But it doesn't have to
even
be
that heavy. That's a good amount of roll, right?
But it's a training intervention. Okay. So it has to be fit into the schedule. But the idea is don't go super go super heavy if you want to be polarizing towards the heavy loads. But of course, before that, you have to be familiar. You have to be, used to that.
You better.
Yeah, of course. But I mean, to me, it's obvious.
But you know what? It's interesting. I've got a heap of back squat experience, but I've never done it ballistic. I wouldn't feel comfortable. I feel like I need a decent amount of familiarity.
But this is an issue because give me a load that corresponds to my 6 RM. So it means I cannot push 7. This is a misconception of many of my students. They think that 6 RM load is the load that you can push 6 times. No, it's the load that you could not push 7 times.
Yeah, okay.
It's very different.
Okay. Interesting.
Because they do 6 with a load that they could push 15 times. You see what I mean?
Yeah,
so
a lot do.
So give me that real 6 RM load.
Okay.
If you don't tell me go ballistic, can move the load at many different velocities. You see what I mean? So in terms of velocity stimulus, there's been studies on that by Rob Newton, the very basic papers of Newton in the 96 or 95.
Yeah, classics.
So if you say push at the max velocity and you make sure that the load will be handled somewhere, etc., then my velocity output is totally different. So I would say that at the start, ballistic training is already a very good velocity stimulus. Because when I enter a gym and I see loads moving, 80% of the time these loads are not moving at the maximum velocity they could.
Well, I mean, the argument is if it's a bench press, they're never moving at the maximum velocity they could, right? Because who's doing bench throws in a
but it's just a problem of technically handling that bar, because you slow down the bar because you need to keep the bar in your hands. But if you were able to just push it ballistically, then the same session would have very different neuromuscular consequences.
So you touched upon there, like 3 sets of 3, very heavy load.
Yeah.
In addition to that, if we're talking contrasting, what would the additional high velocity be?
So with the 3 times real 3RM, we know you are in the first, let's say, 20% of the spectrum. So that's valid for the extreme left side of the curve. If you want to go to the extreme right side of the curve, you need to go faster, much faster than a pure squat jump. So you will need assisted jump, or you will need, that horizontal push, or you will need other ballistic types of actions. So, for example, squat jump is not what I consider a right side of the curve exercise, because when you see the velocity, you're right in the middle of that spectrum. So again, if you do, for example, 3 times 3 RM as the heavy load, that's okay. But if your contrast is brought by doing squat jumps, that's not okay. It's let's say a semi-contrast, which is not contrast.
I just keep getting this vision of the horizontal squat jump and a massive elastic band just firing people across sports halls and smacking their head on the wall. So if you're going to do it, just test it first.
But even without going horizontal, you can have that vertical assistance and you can jump super high.
Yeah, I think did you say yesterday you came across some of that on from Twitter somewhere, and you showed us the video.
That exercise of Craig Twentyman with the SNC coach for the girls in rugby in Australia, and he had that exercise with the girl gripping an elastic band. Her downward motion was just building elastic energy, and then she was using that to jump super, super high.
She was nearly clearing the bar, wasn't she?
Super fast.
Yeah,
that's what I call a contrast exercise. So then in terms of how do I periodize that contrast, do I do 1 week heavy, then 1 week super fast, or do I do that within the same session? That's open questions.
Good questions, right? Interesting.
Yeah, absolutely.
Good questions, though,
absolutely.
Right?
That's it. Some coaches like contrasted sessions. Some coaches like contrasted cycles. There's no clear scientific evidence on what's best, so it's just anecdotal evidence.
I know you said you don't like reps or sets recipes. What would you be putting out there? Is it obviously until the athlete's fatigued?
Yeah,
are you
for
doing
super
2 or 3
fast
jumps?
stimulus,
What we're looking at?
It's not the same demand. It's not the same time under tension. So you can go with more reps in total. So it could be. You want the quality of motion to be preserved. So you can go with, for example, 4 or 6 reps and do that 4 or 6 times. Yes, but the time, the fatigue and the time it takes should be normalized. Like if it takes you 20 minutes to exercise with the heavy side of the curve, then you should go 20 or so with the very fast things. What we observed is that even very, let's say, acceptable stimuli within a typical training context in season had some effects. So we had very big babies, rugby players, pushing heavy for years and still improving their jump weight based on that kind of maximum velocity stimulus.
So one thing you mentioned yesterday that I thought was very, very interesting was a lot of the adaptations in the studies revolved around shifts in the profile as opposed to increases in Pmax.
Yeah.
When I would have expected to see, you'd expect to see both, right? And Matt Payne's counterpoint was, well, they've been training at Pmax for a long time. So, like, basically, I think his argument was that, well, that's already kind of been exhausted, right? Like that's already. Any thoughts on that?
Yeah, we don't really know. What we observed is that yes, in most of the groups where we stimulate one part of the curve as a priority, we observe also a slight or a more important decrease in the other part. So because you understimulate that, and eventually Pmax is either unchanged overall or slightly improved, which eventually results in a higher jumping performance. But yes, is right. We used as subjects people with a good training background.
Yeah.
So maybe people with a Pmax that is plateauing at some point.
I thought that was a really, really fascinating point. But also, it really speaks to the value of your work, because going back to your toothpaste example, right? Like a lot of these athletes, pretty much across the board, if you're doing training, it's usually pretty reasonable by now, right?
Yeah.
So it's really being able to get those final gains, and basically I think that speaks to the power of your guys' work.
Yeah,
can you just throw the tooth? I was literally asking about the toothpaste analogy.
Yeah,
I liked it as well. So
that's it's a very good way to express where is my margin for improvement in training. So basically, if I am a full toothpaste tube, however you press me, I'm gonna give some improvements, some toothpaste, some improvements.
I thought
I like the fact that if I take my daughter's class and I ask them to jog for 5K twice a week for a semester, they will all jump higher and sprint faster, even though I did some pretty endurance work, okay, because they have plenty of margins of improvement. But now if you work with Olympic champions or elite level people, they have been trained for years. Jogging twice a week 5K will do nothing. All right,
it's pretty funny.
It's the same, and you've pressed exactly the same point in the toothpaste, but there's no toothpaste anymore, okay? So you have to find, and you know how to do that, because if I give you an empty toothpaste, you will know how to press and how to get that, okay?
Roll at the bottom.
So the idea is take the athlete, try and find where is the toothpaste left, and then try and stimulate that. And this is what we do. We had some Olympic champions in swimming tested, and when we test them, we see that he has a crazy imbalance in his profile, which means that even though he is the Olympic champion, there is still, theoretically, a margin of improvement for his starting block push-off in swimming, all right? So it means that even if he was the fastest in the final to enter the water, that's in absolute terms. In relative terms, for himself, there's a margin of improvement. You see what I mean?
But I think it's a really important point, because theoretically, what you'd really want to do is, if the person has a velocity imbalance, you'd want to increase Pmax just by increasing velocity, right?
Yeah.
I mean, that's literally but I think the point being is that with a trained athlete who's already trained a lot around the mass of competition, that's already kind of been exhausted, right?
Yeah.
So you're offering them that which I think is a really important point.
Well, in that specific case, it was the opposite. It was improving the foresight of the curve.
Okay,
but let's say if you need to improve that velocity side of the curve, and you've been training for years with your own body as the minimal load, there's no way you can stimulate faster with your minimal load as your body weight. You have to go lighter than that, faster than that. And there is still a margin. What is really amazing to me is where will that faster velocity training lead, because the entire history of physical prep is, in my opinion, skewed towards loads, additional load, and heavy loads. Sometimes it's totally necessary. If I want to be myself as a sprinter faster, I will have to load heavy, because that's what I'm
thought
missing.
You had a 200 kilo back squat, no?
Oops.
we got it.
You got me. So yes.
So guys, we're kind of running out of time. I mean, we've got some amazing things. You've kind of touched upon it in everything that you're talking about regarding individuality, and I think you touched on it a little bit towards the end. But I think what I'm picking up is that the spectrum, the force velocity spectrum, is key. But at an individual level, to coach athletes, how would you go about that in a team environment? A squad in football.
Yeah, that's the job. I mean, yes.
Good question.
Of course. When you have 30 players to manage and you want to go individual, so you should be able to, but realistically, it's very, very difficult. So what we did with rugby clubs, for example, I work with, is trying to group people. So we go semi-individual with these kind of groups. Like you have 30 players, you profile all of them, of course. You have to, but then you try to group people, and you try to make some groups in terms of deficit. You try to find people with the same needs. And basically, when you profile 30 players for jumping and sprinting, you will be able to do something like, let's say, 5-6 groups. Sometimes groups of one. We had an academy soccer team where there was only one guy with a very, very force-oriented profile. He had a different SNC program, and there was only him in that group.
Do you reckon that was just the sample you had, or do you reckon that's actually like different athletes tend to have? Well, they'd have to, right?
Overall, athletes trained for the same sport over the years tend to have some very typical profiles, but on that team, that player was the only one with that profile, and he had a history of weightlifting, etc., because he was coming from Denmark, and so he was trained differently. Okay, but we tend to do some groups. But yes, I mean, individualizing means more work, definitely, but it's easier to do one sheet on the wall and it's,
but this is what we're talking about, elite level, max performance.
I will always remember that sentence from the physical coach of that team in the academy. He said, at worst, it doesn't change anything. You see what I mean? So he said, let's try that, because I do it because the club wants us to have an SNC session, but they do all the same, and I don't really know why what I do is effective and if it's effective. So I
think that's a common sentence to the state of SNC in general, right?
Yeah, but it's because of the numbers. I mean, it's human. When you have 30 players to deal with, either you're a superhero or you have to simplify the approach. So it's way easier when you work with, 2 tennis players or 2 track and field people. So
I think one thing that you mentioned yesterday that I think would be really important to hash over is when you're actually making these profiles, what's the minimum amount of points that you need, and how do you have to?
Yeah, so in jumping you need in sprinting it's very easy. You just need 1 sprint or 2 trials to average the data, so that's cool. But in jumping you need to build a line, so ideally you would have 4-5 points,
okay,
because you need a super high linearity. But some studies recently showed that if you do it correctly with only 2 points, but the maximum points, so body weight, squat, jump, and a very heavy load that you can jump with, you can have the same, let's say, quality of assessment. So you can go with only 2 points if the athletes are used to the test, and etc., etc. So it can be super fast.
It's also good to mention that in the scenario you're putting forth, you don't even need to go lighter than body mass to get your initial line, right? So think about it. If you had a squad coming through and you just and they were familiarized obviously, and you just had them go really heavy and body mass, and you're done, right?
The idea is that if it's a monitoring routine, you can warm up, do the jumps, like 2 trials with 2 loads or 3 loads, do the sprint, so it's all in all 30 minutes and you're done. So it's great. You can decently do that. You can do that every 2 months. Our current recommendation, if there's no injury or whatever, is to do that every 2 months, just to monitor what
that's
changes
nice,
with
it's
practice.
Not super, it's not, they got to train at the end of the day, right? So it's good. It's really good.
Yeah.
Right, guys, that's pretty much all we've got time for. I know that, we could probably be here all day, and I've got loads of questions I've had to hold back, and I know Bill's, chomping at the bit to ask even more.
JB, thanks so much for being over here.
Thanks.
We really are super honored to have you, and it's
great.
It's
my
been a pleasure. Thank you.
Yeah.
Thank you.
Thank you.
We've heard JB talk about how to create an optimal force velocity profile for an athlete. He's explained various training methods to optimize performance for athletes with either a velocity or force deficit. If you'd like to read more of JB's research and access his force velocity profile spreadsheets, then head to jbmorin.net. Thanks for listening to the Loughborough Sportcast. If you want to get in touch and let us know any subject areas or experts that you'd be keen to listen to, then contact me, Martin Foster, on m.foster@loughborough.ac.uk or tweet me at martinfoster82. Bye for now. We'll see you next time.